got this computer monitor out of the scrap bin, and I thought, oh, that's nice, I'll just replace some capacitors and then I'll have a good monitor. Especially good and interesting because it's one of those ones that if you push this in the right way, it folds down so you can use it for like a drawing tablet or something. It's got a touch screen built onto it, which is a bit more interesting than the usual cheap monitors that you see lying around now because their capacitors are dried out. But unfortunately, it works. This doesn't have bad capacitors. The problem is, it's got a crack in the screen. So unfortunately that's not fixable, and if you plug the USB in to make the touch go, it's just continuously touching in some random places because of the crack in the glass. It's also very annoying to find that on my laptop the only display outputs are on the internal graphics, not the discrete one, which is frustrating because it limits what you can use it for. Anyway, we'll take apart this monitor and have a look inside it. I want to see what does the touchscreen join up to. Maybe it won't be very interesting, but we'll do it anyway, since this thing needs to get taken apart to turn into more valuable scrap, I guess. I've just noticed that there are no screw holes. Oh, maybe it's not that hard. Yeah, there's this kind of rubbery thing here. I think that's so that when you have it in that lying down mode, that thing will touch the surface of the table. It's one of those more fancier styles where the glass screen goes right to the edge so that it can be broken very easily. So quite a good feature for them. It makes Dell a lot of money because people have to keep buying new monitors when they break them by something tapping it, banging it. Looks like we can just get it unclipped. Just find a suitable persuader. Maybe I should get some of those guitar pick like things to undo clips. That would be too fancy. Just do it the old fashioned way. It's not like this is going to get any worse. It's already broken. Just that bottom piece, we're covering where the contacts connect onto the glass. A very delicate part. So this thing has got a USB 3 input, or device connection, and then it's got a USB 3 presumably? Maybe not. USB 2 outputs. And then on the side it's got two USB 3 ports. So it has a USB 3 hub in it, but it's wiring out some USB 2 stuff. I guess you put your keyboard and mouse on that, and then you can plug your high-speed devices into the side. It looks like multiple layers come off, because that is coming out there. Maybe there are screws somewhere. There might be some screws hiding under these labels. No. It's like those Samsung TVs, isn't it, where the back is all clipped on. Okay, look at this. Got bottom of the display. That there is probably going to those controls. It's got little buttons along the edge, which I think I just poked really hard with the screwdriver. The USB connectors here got this one-sided shielded flexible cable thing and a metal shield over that. Oh, that's nice, isn't it? Local decoupling capacitors and ESD clamp diode thingies. Good. There are some screws. So that frame thing that I started peeling up is screwed down. Also, really tiny screws in the corner. Guess that's because the whole rest of that is got the connection from the glass coming off of it. Some kind of ribbon thing that's probably the whole length or in sections along there. The LG display LM238WF5. Guess you could find that and order another one of those panels if you wanted to get this going. It's only a 1080 resolution, so it's a bit, well, it's small, so it wouldn't be that. 2560 by 1600 would be better. That seems to be rare. For some reason they've gone to those 1440 ones, which is annoying. Sacrifice the height. What are we taking off? Just that thing will come off. Oh, we want to find out where the touch thing joins on, don't we? Maybe it's integrated into the... and comes as... or maybe it's that. There is a tiny little ribbon there. Interesting little tiny screws there. Yeah, look at that. It's a little control panel thing up there. So that only unplugs that side by the look of it. And that board is screwed in with some really tiny flat screws. Not touch buttons, they're just regular, like little low profile tact switch thingies. Now this thing here you're not supposed to open because that reveals the connections onto the glass, which are very delicate. Let's have a look at getting this cover off. See what the power supply looks like on this thing. There doesn't seem to be a lot going on in there. I think it's just a little board down the side for the power supply. Oh, that comes off. You don't get to see the boards. They come with this. So we'll have to undo these connectors. That's got a nice plug on it. With latches. That's just a regular plug, and then that one there had latches. Okay, I have to undo the USB 3 thingy. So is that black part a shield? I don't think so. I think it's insulation because it's got the power supply there, so they probably boosted the insulation. Yes. This could have some charge on it still since it was powered recently. There's a little metal tab thing to hold that cable. That's using nice, soft, flexible wires. Check this power supply out first, see what that's got going. So that must be, that's the power for the panel. Maybe it's an LED driver thing. There's some kind of chip there. We'll have a look at that up close once we get it out. Some panels have the LED driver built onto them and others don't. That has a latch. Look at that. The connector, power connector, has its own screws, which is good. So it means when you're rough putting the power cable in and out, you're not going to crack those solder connections there. You probably learnt that from prior experience. Power supply board, single-sided with through wave surface mount on the bottom. So there's a chip there. Can we see that? Whatever that is, CM3C28 maybe? Or whatever that top row is. I think it's got 0 then a backwards 2 or something. That does look like an LED driver. Because you can see there, it's got a common 2 pins, which is a positive power supply from that 100 volt capacitor. Then it's got 4 what would be current sinks with like a limiting or protection resistor in series with them. And it's possible that that chip supports more, because there's some pins that look unused, although they could be going to that track there, the return. They probably are, because can't see that on any others, and you can see the thieving pads there, so this has gone through the wave in that direction. So the trailing edge of the solar wave gets pulled off onto these pads to stop the last 2 bridging. And spark gaps. They call it gas discharge tube. A bunch of those in case of lightning strikes. because the charge will go to those sharp bits. The field strength will be the strongest at the pointy bits, so it will arc across those instead of breaking other things, in theory. So it's the switch mode controller I see there. I guess it's one of those things like a top switch, or integrated there. It's got that missing pin to get the voltage creepage between the collector and emitter of the FET that's in there. Was this got an external one? Okay, well I guess, yeah, that version then, it's a gate drive output there. Is that right? No, that's not right. Looks like that's the gate drive around to there, and that is a sensing thing, or power supply for the IC. I think it's sensing, yeah, coming off that pin there. There's an optocoupler feedback, so it is regulated. How many voltages is it producing? So that's a diode. Is there any other diodes? So yeah, so it looks like it's 2 voltages, because that diode there going over to where the LED driver part is, and then that larger one will be for a higher current, lower voltage supply, probably 12 volts at 35 volt caps, so it's probably somewhere around that. And that's the supply that's regulated, which it should be, because this other one will be a sort of unregulated supply, because it's being, the individual LED string currents are being regulated by that IC. I'll try to look that up and see if there's any useful information about that, just so we can have a look at LED driver thingies. I couldn't find any information about that specifically. I tried this technique of putting some that paint type marker on it and then rubbing it off really quickly so that the paint stays in the cracks, and then if you're quick enough, wipe it off the surface of your finger. And I think it's quite hot today and it dried, but we can see the numbers now. So that CM number was not it, it's the top one, OZ582, but I can't find any data about it. What I could find was a few other people with pictures of a similar chip on Google search. But yeah, it's an LED driver and it will have current regulatory type things, a bunch of them, so that from one current level set point it will adjust the 4 outputs to achieve that current regardless of their forward voltage within reason. There's a little op-amp voltage follower thing with a sensing resistor in it inside the chip, so the op-amp will control the voltage across the sensing resistor to get a constant current flowing regardless of the LED forward voltage drop. And you need to do that because inside the panel here, as we will hopefully find out shortly, there will be several series sections of LEDs, and LEDs are not all identical, so you can't just join those series strings in parallel and expect them to share current properly, especially if you're trying to drive them really hard like they probably do in these panels. Let's have a look at the board that does the electronic stuff. Let's get those thingies off. The VGA things. It's gone out of fashion largely now, VGA. Just too blurry. Well, with these higher resolutions these days, the signal integrity of the really cheap cables is not up to it for that analog signal. Oh, look at that. There's one chip that does most of the heavy lifting, the work. And I'm thinking that that is definitely the touchscreen thing. As you can see there, they've got green and white wires that are twisted together, so that is almost certainly a USB connection for the touch panel thing. There's a nice EMI gasket thing, what do you call that? Conductive foam thing that was pushing onto these the top of the USB ports, so it met some compliance requirement, I guess, for EMI. Get rid of that, and then this metal can go to recycling. It's not 100% clean though, because it's got these studs in it, but it's probably a similar enough material. So on here there is that, which is presumably some integrated display drivery thing along with a CPU and all the other business to do the scaling when you input non-native resolutions, support DisplayPort, HDMI and VGA inputs in there. There's probably some EDID ROM things for the these ports, presumably, although that looks like some kind of switch mode thing. Various power supply stuff. Then over here, that there will be a probably 6 or something port USB enator, a USB hub. Well, it says on it USB, and it's directly connected to that cable, that connector that went to the two USB 3 ports. And then you can see over here the USB pair from the touch panel goes around behind that, which is the display data out to the panel, along, and then jumps down there and probably comes up somewhere around this onto a USB 2 port. And you can see it on the other side. Jumps down there, pops back up there. Got test points on it. Where is that coming back up? Somewhere in that. Oh, into that thing. Oh, so it doesn't go into that. I need to look up what that is. Unless I got sidetracked and followed the wrong thing. I think that's the right thing. There's another one there going into that. But that one comes from down here, which is the signal from one of these. Okay, so what's this? Maybe that's a USB 2 hub, and that's a USB 3 hub. They need that? I don't know. We see that's got 6 pairs, so it'll be the 2 high-speed pairs and the 2 USB 2 pairs for the 2 ports. 3 for each one. That's unrelated because that's the control panel. You can see there's a pair coming down to this. That's probably a USB 2 port going to that thing. And presumably those unused pins there will be the USB 3 data for those ports. That's what I reckon. We'll look at what this little tiny one is first, and then we'll have a look at that big one. I'll try and get the number of that thing. I seem to want to focus close today. I thought it was good at doing things like that. That's as good as we're going to get, is it? A USB 2412. Buy it from DigiKey. 2-port USB 2 high-speed hub controller. 2 ports. So, you see, that's a trick, isn't it? There's a trick going on here. The USB 3 chip must be a 4-port hub, and because we've got 5 USB 2 devices, they've split one of the USB 2 ports into 2 ports. That's cunning. So it means that one of these is using a port off of that, which you can see there. It's that one there. So that one's not directly connected, whereas that one jumps down to there, up to there, will take one of the direct USB 2 ports. Interesting. I guess it's cheaper to add a USB 2 hub than to get a more fancy one of these guys. USB 5734. Another thing you can buy from DigiKey. Good. That's a 4-port super speed high speed USB controller hub. Flex Connect. It says 5 gigabits. USB 3.2 Gen 1. Yeah, so USB 3 is another thing that lays over the top of USB 2. So a USB 3 hub has a USB 2 hub in it. The USB 2 pair is separate, completely separate to the USB 3 signals. That's another whole system that just exists on the same ports. And they don't usually connect with each other. So if you're just plugging in USB 2 devices, all this USB 3 stuff doesn't get used at all. And it is possible, if you have a device that only uses the USB 3 parts, you could connect another device to the USB 2 pins on that same connector. So you can actually have an 8-port hub there with 4 USB 3 onlys and 4 USB 2 only ports. Pretty interesting that happened. So that means plugging your USB 2 device into a USB 3 hub won't benefit you in any way unless your USB 3 hub happens to be higher performance or better in some way than your USB 2 hub, in which case maybe just get a better USB 2 hub. Okay, let's carry on taking this thing apart. So that thing fell off. It's just a badge. Okay, so behind that plastic front piece there was a metal strip. Guess that's because they're serious about protecting the connections along the front edge of the display, which we can see now. Well, kind of. There's tape there protecting them, and this metal cover here at the back should now lift up. Yeah, look at that. We can see coming off that board on the back of the panel. Guessing that that connector from the LED just wires straight onto that, which goes to a row of LEDs, or the rows of LEDs along the bottom edge of the panel. Still haven't found out where this touch business is coming from or going to. This is not recommended unless you don't mind destroying the panel. It's already broken, so it doesn't matter. So the glass part is probably glued down to the backing piece. Not sure, would the touch part be a separate thing, or have they somehow made that into the main glass of the panel? Don't know. I think there's more tape around here to peel off, but I don't know if it will benefit us in any way. Not sure how that thing is stuck together. Oh, it's clipped. Okay, so around the edge here, you see that plastic piece unclips, and then once those are all undone, it will let the metal backing part come out. So this will be the connection to the backlights over in the corner. This thing seems to be glued down, stuck down with something, tape. Now, all this business is to try and lift up this backlight stuff. It's too big to easily fit on the bench, so it's peeling apart now. Hoping this backlight piece will come off. That's one thing that we can then investigate. It seems to be stuck down the bottom corner. And because it's been lifted up, it means that the clips along this bottom edge are pushing in even harder than normal. Or maybe there's screws or something else on this bottom edge. Don't seem to want to come off. And there's just a lot of aggressive clips there. There we go. Okay, so now the backlight section is separated from the display glass section. Put that aside for a moment, and we'll take a look in the backlight area. It's got various Fresnel lens type thingies. Is that what they are? Or diffusers, which are to do with focusing or softening the light. And then there's this piece here. It's a reasonably thick piece of polycarb or perspex type stuff, and then it has these dots engraved in the back of it, so the light will shine up into the edge of it, and then it will hit to these dots, which will reflect it forward out the front. And you can see along the top edge is a white piece. It might be, yeah, see, it's reflective on the other side, and that will reflect any light that travels the whole way up back down, so it has more chance to reflect towards the front of the screen. So that's how they turn the light coming from these LEDs along the bottom into light that comes out of the screen. So I think that's just a backing thing, which also has a textured surface to help the light reflect off. Some of these, the Samsung QLED panels, I noticed in there was phosphors along certain parts of it, so they're using what UV light comes off the LEDs to excite some phosphors to brighten up the darker parts of the screen, where the reflection wasn't so good, which is interesting. So now that's just a piece of metal, but it's got in the bottom edge LEDs, which are probably quite tightly coupled into this metal because they'll need to use that for heat sinking. So it might not be possible to get those out, or they'll be destroyed in the process of getting them out because of the amount of stuck down This one's not so bad, but see how much that board's getting bent. That will be cracking the solder joints on the LEDs. So if they're not wrecked already, they won't be in very good shape. So in theory, that's 4 strings of LEDs. They all have a black dot in them. I don't know if that's some kind of dye or whether they're going bad. Dye? Or maybe it's just an indicator for which way around they go. Although interesting, is it halfway along? It changes. Yeah, it looks like it is. It must be a polarity indicator because they show you there the band end is that way. And similarly there. So I guess that's an anode indicator. Interesting, that's the LED backlight. I was wondering if I should try turning this on. Each LED has got 4 pins. It's probably got multiple LED dyes in it. Inside, maybe? Not sure, unless... well, I don't know. You'd think if the multiple legs was just for heat sinking, they'd make them one tab at each end, like some diodes have SMA type packages. SMB, that kind of business. Maybe we'll try turn on some LEDs for fun while we're here, and we use this good power supply thing that we were touching the other day because we upgraded it to that 28 volt business. Do we need that today? Maybe because we could I don't know, energize a lot of the LEDs. I think that was the... was that? I don't know. No, that wasn't the 28 volt cable from the other day. That was just a normal one. That's the next problem, is where is a cable now that I've tidied everything up? Use this chunky one. I don't know if this is supposed to be a Thunderbolt or not. It says on it 40 gigabits, but they might just be lying and have wired all 4 data pairs but not actually made it like properly Thunderbolt compliant. Don't know, but supposedly will support the 28 volts. Yeah, look at that. I hope that's stuck down. Now, because maybe we'll use a piece of this so it's not sticking to the paper. Because we know the direction of the LEDs, we should be able to just bung this on and get something to happen. But we'll need to set the current quite down because we'll try 10 milliamps. And the thing is with this, unless you want to blow up the LEDs, have the power supply off when you connect it. Because if you let it charge up to this high voltage and then you join it to the LEDs, you're going to be discharging the whole output capacitor into the LED, and it's not going to like that. It won't last very long if you do that. But then we're probably going to make a bad connection anyway and cause that same thing to happen. So generally it's not a good idea to just wire up LEDs without some additional current limiting. What do? Set the voltage down. I don't know what the problem is. We don't know what the string, like whether there's more than one in series. There you go. Wow, that's pretty bright with 10 milliamps on it. 2.6 volts. So I guess it is just one LED per thingy. I don't know if we'd be able to run a whole string because one, I don't know where they start and end, and this probably doesn't go to a high enough voltage. How can I get this to attach itself nicely so that we can try running more than one? Okay, they are joined in series. Oh, I can't even see this, it's off the screen. And try increasing the voltage. Oh, there you go. 3, 4. So 13 volts. Maybe we can run a whole string. They're at 20 volts. Yeah, that's the limit of that. I guess that's one string then, is it? Or that lost connection, or I burned something out. And there you go, that's 23 volts worth. That's 26 volts worth. Now that's as high as we can go because we're at the limit now. And so that's 10 milliamps, 0.2 watts. Maybe we should just crank it up harder just for fun. 20, 30 milliamps, 40. Oh, we're hitting the voltage limit. Yeah. Anyway, you can see how LEDs work. It's 4 series strings of LEDs, which are probably compromised because this strip got bent quite a lot. But yeah, that's why the input voltage to the LED driver was pretty high, because those series strings add up pretty quickly. Okay, so now we've got the glass of the panel, and it's attached by some quite rubbery glue stuff. I think it might be a foam tape onto the glass. Okay, let's get that out of the way. Now we've got, you can see stuff in here, it reflects. Okay, the front side is a matte finish, which is nice, so it doesn't look horrible when you're trying to view stuff on the computer. You don't really want a mirror so you can stare back at yourself. So that's where the USB connection went. Presumably that thing will be the touch driver. That thing there will be some kind of line driver for the display data. Comes in on there. Probably EDP or LVDS standard protocol 5.10 actually. 10 pairs. Yeah, so maybe it's 2 links of LVDS, and then that gets buffered by that, and then that gets sent out to these things, which will be some kind of shift register type thing, which decodes the serial stream into the columns and rows and puts it onto the glass where it gets into the pixels. And then there'll be some different power supply things for generating the voltages that the LCD panel needs. And then on the front and back there'll be polarizing filters to orient the light appropriately. Just wondering if we should look up that, find out what that thing is. Is that something we can find? MFSD6. It seems a bit weird, doesn't it? I don't think that's the part number. What about U035B? Thing is, these parts are so unused that they're not publicly available usually. I don't think we're going to find anything about this stuff. The little fuse there, can we tell where that goes? It says there USB P and N. There's a filter network. The USB pair comes off there. Common mode choke type deal. Clamp diode. Then what? I guess it goes somewhere. It's off those 2 wires presumably. Is that those? Which then over to that 2 little holes. Yes, I think that is the touch controller, but that's as far as we can really get, isn't it? It's somehow integrated into the glass on this thing. I don't really know how the capacitive touch things work. There's something clear, conductive stuff printed on the glass somewhere that makes things happen when you touch it. Because of the capacitive coupling between your moist fingers causes stuff to happen. Perhaps we'll just look up the panel part number to see if that gives us any interesting information as a final thing, and possibly find out that we could have just ordered another panel for cheap and fixed the monitor. Okay, so this is an LM238. That you can buy it on AliExpress for $110. Okay, 23.8 inches, 1080 resolution, basic colorness, 60 Hz. RGB, clear, IPS, WLED is white, I guess. Yeah, there you go. LVDS 2 channel 8-bit. This is not wide color range or anything. I don't think you can get any data sheets off this site unless you pay them some money or log in or something. Ah, there you go, yeah. Oh, you can free download it. Well, free download it if you log in. Alright, we don't need to do that. But there's some information about the panel, and that was a look inside the panel and the display and all the bits and pieces. Hopefully interesting, and come back next time, we'll take something else apart. I don't think any of this stuff was really worth keeping or anything. It's just random bits and pieces. Maybe we'll get back to VCRs at some point. Got quite a few more of those to go through. Thanks for watching.